The cosmological principle is starting to fall apart. Even the Big Bang is now under suspicion. What if we were wrong? What if the universe was never as we imagined it? Get ready to find out why. The web of the cosmos, the harmony of chaos. Take a closer look at the universe. Its structure resembles a giant web. Each of its threads perfectly repeats the pattern. According to the cosmological principle, this is how everything is arranged on scales larger than 250 million light-years. Homogeneous, isotropic, like an endless ocean where the waves of galaxies obey strict rules. The Bernardinelli-Bernstein comet. And amid these boundless expanses, in the silent depths of space, an icy giant moves, Dida, the Bernardinelli-Bernstein comet. Its nucleus, 75 miles in diameter and resembling a floating island of ice and rock, makes it the largest comet ever discovered. For comparison, take the famous Hale-Bopp comet. Its size barely exceeds 15 miles. Next to the giant, it seems like a tiny snowflake. Take a look at archival data from 2010. It was there that astronomers found the first traces of this giant. It's like finding a needle in a haystack. Officially announced in 2021, the comet had long been hiding in the Oort cloud, the icy cradle on the outskirts of the solar system. The Hubble telescope confirmed, its nucleus is twice as massive as previously thought, and 3 times larger than typical comets. Right now, it is located in the constellation Reticulum, almost 1.5 billion miles from Earth. To see it, you need a powerful telescope. This Leviathan cannot be seen with the naked eye. But the main event is still ahead. In January 2031, the comet will reach perihelion, passing within 1 billion miles of the Sun. That's 10 times farther than Saturn's orbit. Why is this discovery so important? First, Bernardinelli-Bernstein is a relic of the early solar system. Its composition can tell us how planets were formed. Second, its size challenges existing theories. How have such giants survived in the Oort cloud without breaking apart over billions of years? Scientists compare it to a time capsule. Each image is a key to unraveling the mysteries of the past. Each spectrum is a new puzzle. And although the comet won't put on a bright show in the sky, its silent journey has already rewritten the textbooks. After all, sometimes the loudest discoveries come from silence, from the cosmic abyss. Modern cosmology. Take a look at the Standard Model. Dark energy is a mysterious force pushing galaxies apart. It makes up 68%. Dark matter is the invisible framework of the cosmos. It accounts for 27%, while the familiar stars, planets, and gas make up only 5%. It's like a pie recipe. The flour and sugar are just a tiny part. The main ingredients are invisible. But how did scientists come to these conclusions? First, there's the cosmic microwave background, the echo of the Big Bang, recorded by satellites like Planck. It's as smooth as the surface of a lake, confirming that on large scales, the universe is homogeneous. Second, there's data from the Sloan survey. Galaxies cluster together, but over vast distances, their distribution is uniform. And finally, supernovae, the beacons of the cosmos. They revealed that the expansion is accelerating, as if an invisible sail is pushing the universe forward. Even the latest scientific discoveries point to this. Jades. Imagine, the universe is only 300 million years old. It is as dark as ink. And suddenly, the first lights flare up. These are the galaxies JADES 1400 and JADES 1401, discovered by the James Webb Telescope. Their light traveled 13.5 billion years, like a message from an era when the cosmos was an infant. Just think, these stellar islands appeared so early that their very existence challenges all theories. It's as if a child composed a symphony before even learning to speak. Take a look at JADES 1400. Its diameter is 1600 light-years. That's 1,000 times smaller than the Milky Way. But for a young universe, even that size is a miracle. How did these galaxies manage to grow so quickly? Scientists are racking their brains. Could it be that dark matter was building more actively than we thought? Or maybe the first stars ignited earlier than the models predicted. But the main thing is their role in the era of reionization. These galaxies, like torches, melted the ice of neutral hydrogen, filling the cosmos with light. Without them, the universe would have remained dark and empty, and their infrared glow, stretched by the expansion of space, is like the fingerprint of time itself. Skeptics ask, could this be a data error? But the statistics are rock solid. These galaxies are not a coincidence, but the key to the mystery of star birth. They are forcing us to rewrite the textbooks. It turns out that the first structures formed not over billions of years, but in moments by cosmic standards. What's next? The Webb telescope continues to scan the depths. Each new image is a step toward the answer. And who knows, maybe the next discovery will show that our universe matured far more rapidly than we ever dared to dream. Quipu. Imagine, in the endless void of space stretches an invisible web more than 1,300,000,000 light-years long. This is Quipu, a gigantic metropolis of galaxies, discovered in February 2025. Its mass is equal to 200 quadrillion suns, as if all the matter in the Milky Way were multiplied by an unimaginable number. Hans Bering's team from the Institute for Extraterrestrial Physics, Max Planck. In 2025, they made a breakthrough. It was as if the scientists had found a needle in a haystack. They analyzed X-ray signals from galaxy clusters, located at distances ranging from 424 to 815 million light-years from Earth. And so, QVP became the largest known structure in the nearby universe. But the most astonishing thing is its scale. QVP's length is 1,000 times greater than the diameter of the Milky Way. Why is QVP so important? Imagine, its size challenges our models of the universe. Located at a distance of 424 to 815 million light-years from Earth, it distorts the measurement of the Hubble constant. It's like discovering that the map of your city has suddenly become 3 times larger, and you had no idea. But most importantly, QVP reveals the secrets of galaxy evolution. Its side branches, like tentacles, show how matter flows between clusters, fueling the birth of stars. Scientists compare it to a cosmic aqueduct, nourishing entire worlds. It reminds us, even in the 21st century, the universe is full of mysteries. And just as the Incas once tied knots to transmit knowledge, so too does QVP record the history of the cosmos in its structure. Rebels, 25. Imagine, the universe is only 700 million years old, an age comparable to a newborn's first breath. But even then, in this cosmic cradle, there already existed the giant galaxy Rebels 25. Its rotating disk, like a miniature Milky Way, brought order to the chaos of the early cosmos. Its mass is 8 billion suns. It's as if it's challenging nature. I am here, and I am already perfect. Take a look at the data from the ALMA telescope. With the help of millimeter waves, scientists saw not just a cluster of stars, they observed an ordered structure with a possible bar, a rare feature even for modern galaxies. Rebels 25 forms stars at a rate of 200 solar masses per year. That's like giving birth to a new sun every 18 hours. For comparison, our Milky Way creates just 1 star per year. Why does this discovery turn science on its head? It shatters the stereotype about early galaxies. Instead of chaotic mergers, there's a mature disk. It's like a child being born already holding a university diploma. A recalibration of the cosmic clock. Ordered structures formed many times faster than previously thought. The most astonishing thing is the possible bar. A bridge of stars and gas typical for mature galaxies seems to shout, evolution began earlier than your theories. Scientists are at a loss. How did such complex structures arise in the blink of an eye by cosmic standards? It's like finding a smartphone in the Stone Age. Rebels 25 throws down the gauntlet. Reconsider everything you know about my birth. And who knows, maybe its light, traveling to us for billions of years, hides even more secrets. Is the theory correct? But what if the puzzle has cracked? The giant arc and the big ring, structures spanning billions of light years. They break all the rules, resembling giant cracks in the theory of homogeneity. How could these monsters, twice the allowed limit, have formed after the Big Bang and inflation, which were supposed to smooth out any irregularities? Scientists are at an impasse. For decades, data from the microwave background and supernovae confirmed the model. But now anomalies are multiplying. For example, the mysterious ring in the constellation Boötes. Its shape contradicts the expected spherical patterns. Baryon acoustic oscillations, the traces of ancient sound waves from the Big Bang, are as if someone rewrote the astronomy textbook. And what about the discrepancy in the Hubble constant? As if the universe's clock were ticking at different speeds, in different corners. What comes next? Perhaps we'll have to reconsider the very foundation, the cosmological principle. Maybe dark energy isn't constant, or gravity works differently on gigantic scales. One thing is clear for now. It's as if the universe is whispering that even within its apparent order, there are secrets hidden that could overturn everything we believed in. The giant arc. Imagine, at a distance of 9,200,000,000 light-years from Earth, in the constellation Boötes, there is a giant arc hidden, like a celestial bridge stretched across the void of space. Its length is 3.3 billion light-years. That's almost 3.5% of the entire observable universe. If we could see it with the naked eye, it would cover a portion of the sky equal to 20 full moons. It's like 24 silver discs arranged in a mysterious pattern. Take a look at June 2021. It was then that graduate student Alexia Lopez was analyzing data from the Sloan Digital Sky Survey and discovered something incredible, a chain of galaxies and clusters forming a perfect arc. Scientists called it the giant arc, a structure whose size challenges the very cosmological principle itself. According to theory, there shouldn't be any irregularities in the universe larger than 1,200,000,000 light years. But the arc is 3 times bigger. Why is this so important? First, its shape doesn't fit into standard models of baryon acoustic oscillations. It's like a giant puzzle piece that doesn't fit the overall picture. Second, the arc is located next to the Great Ring. This suggests that there might be an even grander system. Scientists are racking their brains. Could dark matter be involved here? Or are hypothetical cosmic strings to blame, threads as thin as an atom, but billions of light years long, left over from the birth of the universe? Skeptics claim it's just a random alignment of galaxies. But the odds of such a coincidence are like finding a needle in a haystack, the size of a galaxy. The arc serves as a reminder. Even in the era of ultra-precise telescopes, space can still surprise us. And who knows, maybe the solution to this mystery will rewrite the astronomy textbooks. The Big Ring? Just 3 years after the discovery of the giant arc, the same researcher, Alexia Lopez, stunned the scientific world once again. In exactly the same region of the sky, just 12 degrees from the arc, she discovered the Big Ring, a cosmic giant with a diameter of 1,300,000,000 light years. Its circumference is 4 billion light years, so like a gigantic hoop encircling a void. Take a look at this region. Both objects are 9,200,000,000 light years away from us, like twins defying the laws of the universe. At the meeting of the American Astronomical Society, Lopez presented data from the Sloan survey, a ring-shaped chain of galaxy clusters. Its statistical significance exceeded 5 sigma, the threshold beyond which doubts vanish like cosmic dust. But the main thing is its shape. Scientists are baffled. Standard models of baryon oscillations predict spherical structures, not rings. The most intriguing thing is the proximity of the arc and the ring. Imagine 2 structures, each billions of light years across. They resemble pieces of a giant puzzle. What if they are fragments of an even grander system, invisible even to our telescopes? Alexia is convinced this is no coincidence. The odds of such a match are like finding 2 identical snowflakes in a hurricane. While some scientists debate the nature of the ring, others are searching for answers in modified gravity, the idea that the laws of attraction work differently over vast distances. But one thing is clear, each such discovery is like a crack in the foundation of old theories. And who knows, maybe in a decade we'll see a new map of the universe, where the giant arc and the Big Ring become the first letters in a cosmic alphabet we have yet to decipher. A reconsideration of the cosmological principle. But how can we explain the existence of the giant arc and the Big Ring? One of the key mysteries is their shape. After all, baryon acoustic oscillations, or BAO, are the echoes of sound waves from the early universe. They left behind spherical patterns nearly 500 million light years across. However, the arc and the ring are like rebels, breaking the rules. Their elongated and ring-like shapes do not fit into the spherical templates of BAO. Scientists are whispering, could unknown gravitational forces or even cosmic strings be involved here? Imagine relic threads of space-time left over from the Big Bang. These strings are as thin as a proton, but have the mass of billions of suns. They could have attracted matter, creating gigantic structures. For now, their existence is just a hypothesis, but if they are discovered, it would be revolutionary. However, the data shows that strings, even if they exist, account for less than 10% of the universe's structure. Take a look at the cosmological principle. It states that on scales greater than 850 million light years, the cosmos is homogeneous. But the arc and the ring, stretching across billions of light years, challenge this rule. Some scientists propose radical ideas, such as modified gravity, where Newton's laws work differently. Skeptics object, what if it's just a coincidence? But the statistics are against them. The probability of the giant ring being a random coincidence is 1 in a million. It's like finding a diamond in a sandy desert the size of a galaxy. So what comes next? Answers may come with new telescopes. Euclid and DC. They will study dark matter, double-check the data, and perhaps open the door to a new era of cosmology. Prospects. And who knows? Maybe in the near future, the moon will become humanity's second home. Earth's orbit will turn into a bustling space harbor. Like colonies under domes, astronauts extract water from lunar regolith. Tourists admire the Earth from the heights of orbital hotels. Giant telescopes on the far side of the moon study dark matter. Interplanetary ships refuel in orbit before heading to Mars. All of this is not science fiction. It's a logical step in an era where space will become part of our everyday lives. After all, research and development is already underway that brings this scenario closer. In 2025, missions like Blue Ghost and Hakuto are paving the way for lunar bases. The Artemis program is preparing the first woman to land on the moon. Blue Origin is testing the MKI lander, capable of delivering tons of cargo. At the same time, ESA and its partners are implementing the Zero Debris Initiative to clear orbital debris by 2030. Cleanup robots like ClearSpace One are already ready for launch. Commercial companies like SpaceX and Blue Origin are reducing the cost of flights. Small satellites the size of a suitcase are making space accessible even for startups. On-orbit refueling technologies will extend the lifespan of satellites. The New Glenn and Starship rockets promise to deliver cargo more cheaply than ever before. Humanity is not stopping at what has already been achieved. Record-breaking spacewalks, commercial stations like VAST, and plans for a permanent presence in orbit, all of these are pieces of the mosaic called Space Age 2.0. And although challenges remain, from debris to interplanetary risks, one thing is clear. We are on the threshold of an era where the boundaries of what is possible expand with every launch. Outro. For now, the Giant Arc and the Great Ring, Quaipi, and the Rebels, 25 Galaxy, they are like pieces of a mosaic scattered across the universe. Each of them challenges our understanding of space. It's as if they're shouting, "Your theories are incomplete." The Quaipi, stretching across 1,300,000,000 light-years, is like a gigantic gravitational bridge linking galaxies into a single dance. The Giant Arc and the Ring, which violate the limits of homogeneity, resemble cosmic artifacts left behind by an unknown civilization. They force us to reconsider the principles of isotropy. And Rebels 25 is an incredibly ancient galaxy. It proves that star systems grew many times faster than we thought. What unites them? They are all keys to mysteries that science is only beginning to decipher. QPEs affect the Hubble constant. The Arc and the Ring call the inflationary model into question. And baby galaxies are rewriting the history of reionization. Together, they paint a picture of the universe, where chance and regularity intertwine like threads in the knots of the Inca Quipu. Now, telescopes like JWST and Euclid are scanning the sky. Scientists are debating. Some are searching for cosmic strings, others for new forms of dark energy. But one thing is clear. We are on the threshold of a revolution. Each of these discoveries is not an end, but a beginning of a new era where even the boldest hypotheses may turn out to be just the first step toward the truth.